So good evening. We're doing arrays, and my name is Brian Rojas. We have Dulce and Kushpreet, and we're going to be presenting arrays. Go ahead.
Arrays, yeah. So quick overview of arrays. An array is an object used to store a collection of data. All data stored in an array must be of the same type. So if it's an int, it must be an int, and you cannot have a double inside an int. And arrays are the most common data structure. Arrays have a fixed size, and once it's declared as final, you cannot change the size. It's not going to grow or shrink. And syntax for declaring arrays is down here. And it is also on the notes that we uploaded to Blackboard.
So unordered arrays are the arrays that really have no consistency. And in searching time, it's big O n time. For deletion, it's big O n time, and insertion is big O one time. So this is perfect for when you need to insert really quickly, and the order doesn't really matter.
And up here is this is what an unordered array looks like.
An
Example. So ordered arrays are ordered. As you can see up here in the example, it just goes from 1, 2, 3, 4, 5. These have some type of order to them, whether it's increasing or decreasing. So they could be decreasing from 5 to 1. And there are various ways to sort these arrays if they are not sorted already. And these are some of them. These are the simple sorts and advanced sorts, which is another topic. So we can't go into that one.
Yeah, we're just going to talk about the relation to arrays. So with quicksort and merge sort, we can see that on average they have the same time complexity. But merge sort is less efficient than quicksort because it uses up more space, especially for larger arrays. And then selection sort, it has the best average case of big O n squared. Because no matter how the array looks like, we still have to go through all the values, no matter if it's sorted or unsorted. And bubble sort, best case is when data is already sorted, there's no swaps, and the sort ends. And then it's worse when the smallest element is at the end. So when it's increasing to decreasing. Yeah. And insertion sort is best for almost sorted arrays. There is one reason why it's basically the greatest advantage to using ordered arrays, which is the search time. And only if you use binary search. Your search time will be big O log n, which is really good. And then there are also disadvantages. Insertions and deletions are very slow. It takes big O n time, and this is because you have to shift elements either to the left or the right in order to accomplish this. So this is good for situations in which. So this is good. So this is good for situations in which searching is frequent, but insertion and deletion is not. You don't want to do that.
So she mentioned binary search, and how binary search actually works. It looks at the middle item of the array, and from there it knows what area of the array to eliminate, and no longer search for that. And then towards the right we have the actual comparisons, either comparing binary search versus linear search, and you can see the differences there with the data from the array size. Big difference when you get to the bottom.
Binary does 20, here in linear a lot more. Yeah. So for our project, we decided to use a Twitter's API, and we're going to collect the data based on hashtags, and whichever candidates, we have 3 candidates, Sanders, Hillary, and Trump. Whichever candidate has the most hashtag to them, that is how they're that's.
So yeah, so the hashtags are connected. So we have 3 candidates, and we chose 3 specific hashtags for them that are in favor of those candidates, and then we gathered tweets with those hashtags, and then we counted how many retweets per those tweets we had, and that's how we
ranked the
that's how we rated
yeah.
popularity. So the more retweets, the more popular.
It would have been easier if Yeah, if it would have been easier if Twitter was a little bit friendly, but
They limit us to 100
Yeah.
tweets
Searches.
per search, and we
Yes.
also have a time frame to get an actual token and all that. So it gets really complicated. But we were able to pull it off.
Yeah.
and
We can demonstrate that. So
it'll run.
So right now, it's just, yeah, go ahead and hit update. We're going to search by the state in California, and it's going to give you the results for each candidate. So these are actual live tweets, and they are the number of retweets, which calculates the popularity for each one. And you can actually switch to, right now we only have 3 states, but
Yes.
it is working. We can add more in the future. It searches by geolocation.
So when you pick Ohio, it actually puts another graph next to it instead of overwriting the previous one.
For comparison.
Yeah.
So.
And then you have Texas. And this is all, like currently, these are only based on like 100 tweets. So it might not be that
Each-
accurate.
Yeah,
100
each
tweets per hashtag.
So
per
each
hashtag.
candidate has 300 tweets attached to them.
Yeah.
Yeah. I mean, we can scale it.
But yeah.
This is it.
QR code. You're talking about what we want to write.
Okay, so to actually connect to the Twitter API, there was this tool that was already created for us, and it was Twitter 4J, and that's what we use. Go to the, I'm going to scroll down to the credentials. So this is our actual credentials to actually get in, and we each have to set our own token and actually make an account with Twitter to pull this information.
So the token, the secret, and the
Just
there's one more. The consumer secret is what changes after 15 or so minutes. It wasn't really consistent because sometimes we couldn't use it after we used the token for a few minutes, but sometimes we could use it for like over 2 hours. So we're not really sure. Even their API use their examples. It doesn't work. So this was, we're not sure exactly how long we have until this thing like expires. But yeah.
And you know how Twitter is huge, you'd think they have a pretty good documentation about their API, but sadly,
But it's out of date.
maybe it's too complex that it's just too
yeah,
much.
they updated it.
Okay, so we actually pool the data by sending it a location given. So we have presets. It's not in this code section right here, but we have presets for California, and we get their actual coordinates, longitude, latitude, and then we send that in, and we're actually searching for hashtags here, and then the candidate, and that's what it outputs a result, and then it's counting only for the retweets. We can actually output right now in the console every single tweet that we count if you guys want to see that.
View the tweets. Yeah.
You can uncomment at the bottom there. No, it's not the one. Go down.
Keep going.
Right there, yeah. The top and the bottom one.
Okay.
Not that one. And then show the console. So automatically, once it begins, it will search for California. And then it's the hashtags it's looking for. It actually tells you the number of tweets we get, which is only 100 because we're limited.
Yeah.
But then the number of retweets.
There's a geocode. But this is based on like location. Then we have to search in a radius of 320 kilometers because the code itself is just a location. So you have to like go around it to see how many tweets you want to collect from that area. Otherwise, you go out of that state. So we weren't really sure how many kilometers. We just picked 320. But yeah.
And then it tells you down here the candidates. So we're actually storing, in the array, we're actually storing objects for the candidates. We have their basic information and their actual retweets, which is the total. Yeah, that's the candidate's object. And that's pretty much how this runs.
Yeah.
We can show him the chart, how we use the Java FX to create the chart.
You needed
I need many library.
you need all these libraries.
But as we just get the information, we draw a nice chart, and then after we click on that button to update off the combo box, it actually pulls in more results, and it puts it into that data. Yeah, the bar chart.
Yeah. Pretty good. Yeah, that is pretty much it.
And you guys didn't use tools to make this, you actually like...
No, we did everything for the
Nice.
grade and everything.
Good.
A lot of tweaking.
Yeah, they only had like a day because we just figured out how to use the Twitter's API
Yeah, it
yesterday,
takes a
Yeah.
little while.
like in web dev, like around 6 p.m. So all this is after 6 p.m. So yeah. So that's it. You guys have any
Do you
questions?
guys want to post your code discussion board?
We can post it.
Okay, because I don't know, you guys that are interested in looking at this code, that's pretty sweet code, that's pretty nice. Good job, guys. Give them your attention, simple sort.
All right, I'm Bruce Lyman. This is Stephen Allen.
Guys,
We are doing simple sorts, which consists of bubble sort, selection sort, and insertion sort. Bubble sort is a simple and well-known algorithm. It is mainly used as a tool to entry-level programming classes to help people understand sorting. It belongs to the O times n squared sorting algorithms. It is known for being very stable and adaptive. The algorithm consists...
Yeah, you can just minimize it.
Algorithm consists of comparing each pair of adjacent elements from the beginning of the array. If they are in reversed order, swap them to the correct order. And if at least one swap has been remade, repeat the first step. We have an example of this in an unsorted array. It compares the 5 to the 1. When the 5 is larger than the 1, it swaps them. Compares the 5 to the 12. That's good, so it doesn't swap them. And it compares the 5 to the negative 5, or the 12 to the negative 5. 12 is larger, so it swaps them, and so on. All the way, and it continues around until the array is finally sorted. The scenario times for bubble sort are the average and worst case. Sorting times are both O n to n squared. And it is adaptive, which means it has a time of O to the n for arrays that are almost sorted. Selection sort is next. It's known for its programming simplicity. It's inefficient for sorting large amounts of data, so it's preferably used on smaller amounts of data. It's part of the O to the n squared sorting algorithms, and it can outperform other sorts in certain situations. The algorithm consists of the array is divided into two parts, the sorted array and the unsorted array. The sorted array starts empty, and the unsorted array starts containing the entire array. The smallest element in the unsorted array is found and added to the end of the sorted array, and you repeat this until the unsorted array is empty. The example of this is it searches the entire unsorted array, finds the lowest number, and inserts it into the green sorted array, and this repeats as necessary. And then by the time it gets done, the entire thing is sorted in perfect order. Scenario times for selection sort, the average and worst times are O to the n squared, and it has a time of O to the n with an almost sorted array. The final and third one is insertion sort, and it's known for sorting small arrays of data. It closely resembles selection sort, can be used to improve quicksort, belongs to the O to the n squared sorting algorithms, outperforms bubble and selection sort in most scenarios. Binary search is commonly used to find the proper place for insertion. This is regularly called binary insertion sort. The algorithm is very close to selection sort, as it's divided into two parts, a sorted array and an unsorted array. But this time, the sorted array starts off with the first element of the array in it, while the unsorted array contains the entire rest of the array. Unsorted array takes the first element inside it and inserts it into the sorted array, where it is compared to the prior element and shifted if necessary until it is in the correct position. You repeat this until the sorted array is empty, and then your array is completely sorted. An example of this, where it starts with a 7, and then it takes the first one in the unsorted array, compares it to the one in there, and then it puts it in the correct location. And it continues to do this all the way until the array is sorted. The average and worst case times are O n to the squared, regardless of the insertion method, and it has a time of O to the n with an almost sorted array. It has a time of O to the n log n when binary insertion sort is used.
Okay, so going through the code, I ended up using Window Builder to build this applet here. So you get to set what the smallest number you want in your array, the largest number in your array, and your array size. So in this case, 150,000 numbers are in this array. As you can see, your bubble sort here is super inefficient. We're looking at 16 billion times I went through the code just to put everything in order out of 150,000 array size. Your insertion sort is your fastest by far, doing that in a third of the time, and selection sort is twice as slow as your insertion sort. So you end up with bubble sort being very inefficient, getting close to your n squared, your insertion or your selection sort being second, and your insertion sort being your fastest. So 31 seconds, 10, 3 seconds. And the way this code works is you run the code. Smallest number, you pick any number. Largest number, you pick any number. And array size. And this computer's pretty quick at it. It'll run through it. And while it's happening, the GUI is actually broken down. It takes in your initial, your ending, and your array size. I found the only way to get the random number generator to work is build its own method right here. So every time it builds a number, it actually has to call back and bring in a new number. And then I ended up duplicating all the arrays so they're exactly the same. Then they're pulled straight into a bubble sort, an insertion sort, and a selection sort class, which are the ones from class. And when we're going through the GUI, everything is done in an if statement. So it goes through, if you fail to do one thing, the code won't run. One issue I did have while programming this is strings only go up to an int size for numbers, so I could not include the commas. So all this is run in longs, so all these are actually larger than ints. And the time is still recorded in milliseconds, but divided by 1,000 to half seconds. Is there any questions?
That's it.
Again, Steven shared his code, so you guys can take a look at that code.
And it works with your bubble sort, your selection sort, and your insertion sort. So you just plug it in and it'll work.
And he used Windows Builder. I don't know if we used Windows Builder in here, but that's a tool in Eclipse.
Hello.
All right, give your attention. Are you guys ready? Yes, this group is ready, so everyone give your attention. Stacks and cues.
Okay, we're the team number 4, and those are my partners. It's
Robert,
Matthew, and Belinda. And we're going to present stacks and cues. Okay, stacks and cues are... Stacks are straightforward and simple data structure and retrieve elements in reverse order as added. And queue retrieves elements in the same order as added. And there is some pictures, but I'm going to explain them like later. Okay. Yeah,
stacks allow access to only the last items inserted. Once an item is inserted or removed from the stack from the top, or like last in first out rule, LIFO, is it kind of LIFO, which means that access is allowed only at one point of the structure, normally turned to the top of the stack, as it can shows a little bit in the picture, and elements are stored in order of insertion.
Okay, this one means like there is only one way to go inside, and it's the same way it's gonna go outside, something like that. And some basic stack operations are push, to add an element to the top, and pop to remove the element from the top, and pick to examine the element.
So yeah, like the stack elements, like is the stack method, like it constructs the stacks with elements of type E, as it was used for this method in particular. As push value, like it places the given values on top of the stack. Well, the pop method removes top value from the stack and returns it. Throws the empty stack exception if stack is empty. And the peak returns top value from stack without removing it, and throws empty stack exception if stack is empty as well. And the size returns the number of elements into the stack, and it is empty. Returns true if stack has no elements at all.
And this is the stack view, like you guys can see, how push works. Like you have some elements and you're like putting them. This is how it ends up. And pop is like to take them out, and you have to take them out the same way like you put it in. And there is one, like I hope it works. It's an animation. Okay, so we're gonna enter like some values, and with that push thing, I'm gonna enter some more values.
Try doing it just like 3 for this one.
Okay, and that's what push does, and pop, it's just like taking them away.
In the first.
The top, yeah. And pick, it shows you the top element.
You want to talk a little more?
Application of stacks, direct applications, page visited history in a web browser, undo sequence in a text editor, chain of method calls in a Java virtual machine, validate XML. Some indirect applications would be auxiliary data structures for algorithms and a component of other data structures.
Okay. There is queues. They remove elements in the same order they were added, and with FIFO, first in, first out.
FIFO would it actually be?
FIFO.
Yeah.
Elements are sorted in order of insertion, but it doesn't have indexes.
Yeah.
And they add items to the end of the queue, and they axe and remove from the front, like something like you guys can see, like right here.
Yeah.
It's just like a kind of funny animation. Okay.
And basic queue operations, like add for in queue, where like adds the element to the back, remove or dequeue moves the front element, and peek examines the front element. And yeah, and some of the same methods, kind of like same, like what you expect, kind of like same thing with the stacks operations.
Those are the most basics, and there's like some other more, like the size, and it's empty.
But it's basically the same. It just has to do with
Yeah. Okay.
And this is the queues view.
This one is just pushed in, and then to add, and then to remove is pushed out. So data one goes in, data one goes out.
There is a animation.
I think this one is slow.
don't know if it's working. Oh yeah. Okay, this one is adding elements right now. This is how. This is how it looks like after you add all the elements you have. And when you're trying to take it out.
Or, yeah, pretty much the FIFO rule, first in, first out.
And that's how we have to sort this one. Yeah. Oops.
And the applications of queues for directly would be waiting lists or for bureaucracy and access to shared resources, like, or for example, a printer and multi-programming. While indirect applications would be auxiliary data structures for algorithms and components of other data structures.
Comparing, basically this is like an array list. An array list returns true if the stack is empty, returns the number of elements in the stack, returns the top element in the stack, returns and removes the top element in the stack, adds an element to the top of the stack, returns the position of the specified element in the stack. This is basically just simple procedures of the stack. Queue, you can see same thing, add element, remove elements, returns elements. And that's just comparing different values.
And nodes and linked lists, like a linked list which consists of each node of the contains of the elements, and each node is linked to its next neighbor. Thus, a node can be defined as a class as followed with the example code right here, and it shows the output.
Links one node to the other one, the second one.
And this is the code we got from a website called Tutorials Point for the stacks and queues, and which we will show right now for the example. Okay.
You know.
Here, I think stacks and queues, and which is a. You want to try? Okay.
Alright, basically this is just a compiler of a stack.
You want to like play it out?
Oh no, it's cool. Anyways, the class interpost, these are the private variables.
Here, I can do it for you.
Cool. This is a constructor for the input string, and basically it creates a new stack array size. Within the string, I'm sorry if I'm not talking loud enough.
Would you want me to talk, or you want to keep going?
I'm good. I'm just gonna.
Okay.
All right. Where was I? Okay. Creates a default constructor for the input string, stack size, input length, the stack, and creates a new stack array size for the string. This class basically runs through each case, checks to see if these variables are within the string itself, and if it isn't, it breaks. If the stack is not empty, it outputs the top value. Public void got operator char optus and priest one basically checks if it has any of the operators like plus or minus, and it compares it within the stack. So basically, and it has a main method. So basically, I stepped into. Oh, okay. Here I go. Got it.
Console output.
Okay. Step into we're stepping to.
I think that's the rate.
Yeah, okay. Alright, so right here it's checking to see if any of the public trial, let's see. Push in, oh, step into. So right here it's basically showing the values, and it's pushing them on top. It's going through the string. It goes through the array length, and checks to see if they're okay. Basically, you check to see if there's any of these variables, and it checks to see if the top of the stack is empty. Pops off the top. That's the definition. Checks it to see if there's a parentheses. Checks, and if not, checks to see if there's a plus or minus for the next value. Compares the operator and puts whatever it finds next onto the top of the stack. It does it again. It just keeps going throughout the whole string to check if there's any of these variables, plus, minus, or parentheses. Step over. Yeah, it just keeps going and going. It reads through the main method. So basically, right here it goes through here and sees if what's next, and if it finds a what do you call these? Asterisk. If it finds an asterisk, it puts it on top, and then it keeps going and going until it reads through the whole string, and it outputs the new string right here. And this is the stack array in which it goes into. These are just the methods in which it does, like you saw on the slide: pop, peek, empty. If it checks parentheses, if it checks operators, yeah, cases and switches. But that's pretty much it. It just goes through the whole string and does. It's similar to a queue, but it's going through the stack. It's going through the queue and putting in a stack, if you will. Yeah. That's it. So the output is, it reads this, and then it just keeps going. Basically, it doesn't find any of the parentheses, so it basically skips over the parentheses and just outputs the operators. All right.
So it puts it in postfix notation. Do you guys know what postfix notation is? It's how a calculator kind of calculates things. So it puts the two operands, and then the operator comes up.
Like a scientific calculator?
Yeah, it's all calculators. So it takes, like, how we write our arithmetic expressions and makes it so a computer can operate. So it's putting it in postfix notation.
Yeah, I can.
And stacks are used for that.
Stacks are used for queues? Oh. I didn't know the difference. Really. I know the difference, but it's not.
Introduce yourselves. All right, so I'm Mark.
I'm Juan.
Chris. And we did linked lists. Load.
Is it loading?
Yeah, it's loading.
Okay. In computer science, a linked list is a linear collection of data elements called nodes, pointing to the next node by means of a pointer. It is a data structure consisting of a group of nodes which together represent a sequence.
In the simplest form, each node is comprised of a data and a reference, in other words, a link to the next node in the sequence. More complex variants add additional links. This structure allows for efficient insertion or removal
of elements from any position in the sequence. So instead of like an array list where it's, you know, aligned or already have predetermined indexes for each one, this one's just like pointing to a brand new node that you just create out of nothing.
Some of the benefits is that a linked list works better than an array list when multiple removals and additions of nodes using iterators are required. Linked lists only have to change pointers, while array list must shift all the remaining nodes it contains. It uses less memory than an unfold array list because an array list must allocate memory for every initialized node.
So like if you have a giant array list that you created versus a linked list that you only have like 2-3 elements in, then you're going to have a decent RAM difference. Otherwise, if they're the same length, it's not going to matter.
Linked lists also have a higher efficiency than array list when you reuse existing iterators to insert and remove nodes. It doesn't have a maximum length since the size changes dynamically when in its contents. With its contents, sorry.
Because when you delete a node, it just makes it shorter instead of having a gap there or a null space. For any given node, array lists are much faster at random read access than linked lists because a linked list can only move linearly. So you already have a calculation that'll basically help you find each item in the linked list versus array lists where you have everything already pre-indexed, so you can just find it like that. In linked lists, you got to hop from each one, or over, so you can start from the beginning, go all the way towards the end instead of jumping right to it. Each node of a linked list uses more memory than an array list node since pointers to the next and previous nodes are also stored. So you have to use some memory also to tell you where each node is, of course, in the RAM. Adding or removing nodes in the linked list without iterators is ON. So it's going to take a little bit longer than doing it with iterators. Because with iterators, it's O1. So this is just a visual representation of a singly linked list and a doubly linked list.
A singly linked list is just simply a list with pointers to the next element. If you are traversing a singly linked list and you want to go back up, too bad. You have to start over from the beginning. So that's why in class we implemented a doubly linked list for our class assignments. But bear in mind that the more you add to the node, the greater the space complexity of your linked list will be. So you can add a bunch of stuff, but you have to be aware that the more complex your node is, the bigger the size it's going to take.
This is basically the class and where it's kept inside the entire Java language. It shows the parameters and all the implemented interfaces that can be used along with linked list class.
This specifically are the add methods. So when using the linked list, you can use any of these methods to add to the list, depending on what type of list you're actually using.
Get methods, so these are going to return whichever index you're trying to get, if it's the first, the last, or index.
Or get a specific position in the list.
Yeah.
Okay. These are the peak methods. They retrieve the first elements.
They just return the head, so you can take a look, but it does not alter the list. Remove methods, pretty much the same. Just removes elements. You can remove last, the first. Other elements, you'll notice that you've probably seen that there are some stack and queue methods that are exactly the same. This has push and pop, which are add first and remove first. So there's a little redundancy as far as that goes. A lot of the real-world implementation of linked lists will be in stacks and queues. So you'll see a lot of similarities. Oh yeah, so these are inherited methods. Iterator. These are the classes. Abstract sequential list, abstract list, abstract collection, and so yeah, all these are available.
I got this code from the book we use. This is just to like, oh well, the first half is just to test like an array list, but we were just looking at the second half on how like basic the linked list, like some of the methods are like the adding red to the list at index 1, or removing the last item that was added.
So data structure operations, this basically just shows you comparing a singly linked list and a doubly linked list in terms of how long it would take to do several tasks such as access, search, insert, all that kind of jazz. The linked list allows for constant time insertions or removals using iterators, but only sequential access of elements. In other words, you can walk the list forwards or backwards, but finding the position in the list takes time proportional to the size of the list.
These are just references to our links from like pictures and codes we got.
And then Chris has a wonderful program here.
Okay, so this is our project. So I wanted to implement a linked list methodology using, well, as a real-world implementation. But I didn't want to do stacks and a queue since there's already a separate category for those. So something I thought of was maybe make an image viewer. Let's see. Where is it? So this is written in JavaScript, and you add images in, it reads them in as files, and adds the file information as the source to the image. And you can step through. The thumbnails on the image are the previous and next nodes. You can click on them and step through your list. If you want to display the list, you can. This iterates through the list and creates an HTML element for each node in the list. There's peek. You can view the list head regardless of where you're at in the image viewer. You can remove the first, remove the last. You'll see when you get to the end, it moves you up one and sets this as, this image will represent the null because the current image's next is now null since we deleted it. Step up, can remove the first, and you'll see that the same thing applies until you delete everything. And your list is now null. And you can go and re-add images. So, you can take a look at the JavaScript. So this is a representation of the node. Oh, you can't see that. Please zoom in. Remember? Every time I do that, I screw it up because it's never Control Plus when you want it to be.
It might be in preferences and edit. Fonts. Yeah. That looks like Courier. So yeah. Put it like 20 or
Did you change the courier or the?
something. This one.
I think it was
Maybe
code
select
font.
all first. And then try it.
I should change it. I think.
It was code.
The code view.
Oh yeah.
Yeah.
It does pay to here, you can get that something.
Okay, so this is a representation of the node. Obviously, this is our value. It's a string that will contain the source for the image. Next and previous are set to null.
That's how you describe an object in Java.
Yes. If you don't know any JavaScript, just bear with me. So it's a little weird. I had a tough time learning. Try to think about object orientation in terms of JavaScript, which isn't the easiest. Java is much nicer as far as that goes. So for each list, we have a head element, current element, and in its first Boolean value, so I can tell when the list is empty, if there is an element. And so these are the add last function. Should be pretty familiar since we use these in class. It's going to be the same type of method or function regardless of which language you use. Add first, remove first, and so this is pretty standard. I mean, I tried to separate the actual linked list methodology from the HTML so that it will be sort of a pure implementation of the linked list than just kind of winging it. So if we go down,
The algorithm's the same.
yes, it's same regardless of the language you use. Like this iterate method. So you start at the current, which equals the set it equal to the head. So you want to start at the beginning. So while current is not null, you just step it down. And then once you get to the end, you it will be null, and you return the previous. So anyways, the rest of this is HTML. I don't know if you want to go through that. Or jQuery. It's just fading the image in and out. Lots of Boolean checks in order to get this to work, because you have to know where you are. You have to use the current, this dot current for the list, and keep track of where you are, so that if you add an element and you're on the end, oh, didn't show up. There it is. It shows up. Anyways, that's it.
Sign out real quick.
Any questions on linked lists?
What's this?